In the previous video, we introduced how to implement the stack template using array. That's pretty straightforward. So the array implementation of a stack is pretty easy and efficient. But the disadvantage is because every time when we don't have enough capacity, we always double. However, the capacity for the rest of the stack life, if we pop, then honestly, we don't use that again. So we always double the capacity when we need that. But when we don't need that many capacity, actually we don't have the auto shrink for that. So that's why we have another way to implement the stack template is to using the linked list. About the linked list you learned from the prior courses. You know we only need a node, then we add to the linked list. Whenever we don't need that node, we need to remove that from the linked list. So that's why they will never grow too many empty space, because all the empty space, they will be gone. So that's why we don't really have the capacity issue in the linked list, because we only add when we need. So then when we don't need that, we just remove that. So that's what talk about how to using the linked list implementation for the stack. We just need to use the singly linked list. So the public interface for when we're using the linked implementation, the list implementation should be the same as your array. We still need to provide the member function, push and the pop, and the pick. So we'll be able to clear or check if this stack is empty and to know the size. So that's why here your linked list public interface will look like that. So you will see here, right? So we see the public interface first because the private part, they may be different. So that's why we should still have the constructor function. We still have the push, pop, and the pick. Then we have the clear, size, and empty. Right, because the linked list is always dynamic memory. So that's why we should have the destructor function and the copy constructor and the assignment operator. Then come to here to see the private data. We know every time when we create a linked list, actually we already create each node is an object. So that's why we have a struct is node. So this node, we always have the pointer. So this pointer we use for this stack implementation, we only need the singly linked list. And also we will show here is we're using the next pointer to refer to the next node. So then here we will show you later why we're using the next pointer. So then they can be perfectly to show us that's the stack implementation. So then the value we want to store actually will wrap in the node struct. So that's why the V here actually is the V value we store. Then right, we still, every time when we start the linked list, we need to have the first node. So then we can continue to know the next. Then right, we also have the size. Then you can see we have no more capacity for the linked list implementation. So then here we will show you, if you want to use the linked list implementation, then we need to have a dummy. So then we will show you why we need to have a dummy. So the first thing before we show the linked list, we just want to review. I just want to review a little bit about how the linked list work. So we do have those private data as our node, and we have the first node. Then we have the size. So now let's review a little bit from the 165 how you learn the linked list. We just focus on here. So then later I will show you how we will implement for our push in our header file. So in the linked list, remember we need to know what data you want to do. So we just say, for example, we want to create a student linked list. So we have a struct, a student. So the student will have a name, ID. So then that's using the next to refer to the next student. So did you remember how we start growing our linked list? Right, we always need to have the first student, or we say the first node. Yeah, since here is our object is student, so we say first student. So that's the pointer. From beginning, they should equal to 0. Then here is how we will add a new student. So we will using the dynamic memory. So that's why you will see your student temp. You will have a new student. So then we can assign the name and the ID. Then after you assign the value, right, this true line is very important. So this true line is after we have the first node, first student. So then we always add this true line to connect the new node, the new student, into our linked list. So we always have the new node next equal to the first student. Then the first student equal to the current new node. So this true line is very important. That's how we add the new node into our linked list. Do you remember how that happened? So in order to help you to remember how that happened, so that's I want to show you in the picture. So this one, the same thing like earlier, so we have the student struct. So then we create a temp student. So then that means assign the name is Cortana. So then the ID is 123. So we have the next. The next, if we don't assign, so then they give the 0. So right, you see your first student start from 0, right? That's before when we start. So then the most important thing, how we will connect the new temp to the first student. So that's why you will see, let's see how that happens. You always have this new node, the next pointer point to the first node. Okay, but the first node actually, because you are assigned this next equal to the first node, right? But you are not point to the first node, because first node is what? First node is a pointer. So that's why we need to see this first node point to where? Point to the node pointer. So that's why actually when we say the next equal to the first, actually it means where the first student will assign to, the next will assign to that. So that's why you see next will assign to 0. Then first node will assign to the new temp. So that's why they become like this. Okay, so here I show you in the JAWS. So then let me show you in the PowerPoint file. So here is what that's line for. So you see here, that's our new node. Because the student first student point to 0. So that's why you see we here have two lines. You're always using these two statements to add a new node. You see the new node next equal to the first node. Then the first node equal to the new node you create. So that's why you see here, because the next point to where the originally first student point to. So that's 0, right? So that's 1. So then afterward, you see your first student need to refer to the new node. So that's the afterward, how they look like. You see, after these two statements, so here I show you, one is this one. Your next is point to where the first student point to. So they point to the 0, no pointer, so I point to 0. So then, second statement, first student point to the new temp node. So that's why they look like this. So this example actually is you add the node to the beginning of the empty list. Because first beginning, your first student actually point to the no pointer. So we have no node in our linked list. So afterwards, you see we have one node. Then the same thing, you see, can you add another node? So after you have first node add, you see that's the first node point to this Cortana. On Cortana next equal to no pointer. So then, right, so that's now how about we create another temp one. we have Siri and the student ID 432. So whenever you have a new node you want to add, you always have your new node next point to your first node. So your first student is what? You see, when you assign new node next equal to a first student, actually is where this first student point to. So they point to this object. So then that's the 1. So then the 2 is what? Then this first student will point to the new node. So after this 1, then 2 actually become like this. So that's why you will see here, this one is your first student node you add. Then that's the second one. So then you can see if we do the next pointer, then we add like this way. They will always have the first node point to the newly added node. So then you see you have the first node actually become afterward. So now can you see how you will do the second one? If I have a temp2, it's Alexa A52. Right, so when you add the new node temp2, the same thing, you copy these 2 lines. After you create a new node, right? So right, then you just have temp2 next equal to the first student equal to the reference for the temp2. So that's why they look like this. So did you see you have your linked list? And this linked list look like the stack we need. Because all the stack, when we add in the first one, adding the second one, adding the latest one, we always want to access the latest one. So then on the other hand, since you have the first node, right, you also know the first node actually point to the latest node you add in. That's our stack we need. Because the stack, when we want to pop the first node, the latest one. And when we pick, we want to pick where the first student is. So that's the review for your linked list. You can post a video and also make sure you write down the question if you have any. Especially if you are not so familiar with the linked list from the prior courses, you should make sure you read this video. Repeat to watch that to make sure you understand. So after you understand how the linked list work, so then when we become our stack template using the linked list implementation, then you will see here our push. Our push, the same thing, we only need to have a value. This value will help us to create the new node. So this new node temp value equal to the value. So after we create this new node, we always have this new node temp next equal to the first node. Then the first node equal to temp. So that's how we will create the stack. Add new value to push to our stack in the linked list. Okay, so let's see how our complete code will look like. So the first one, you have your class declaration. We have our struct node, the v value, so the next pointer for the node pointer. So then you have first node, you have size. So then we will have dummy, so I will talk about later. So we have constructor function, destructor function, and the copy constructor and assignment operator. So we have push, we have pick, we have pop. So then the same thing, you can see the size actually just a getter function in line. So then we only need to return the size. So the empty, again, that's a conditional operator, so then we can do that. So then clear, later we'll talk about more about clear. Clear here will be different from the array. So then actually our push, you see, here's our push. So our code I showed you earlier, right? So the push, right, I have the value. So then you see I have the new node. So the new node we can use in the C++11 syntax. So then you see I have the value. So if you want, you can use. So we have the new node with the value equal to the value. Okay, so if you're using the braces, you see here we give them the no pointer for the next. So you create the new. Okay, so then you see you always have the new node you create the next equal to the first node. Then first node equal to temp. So that's the push function.